Hello, everyone. Good morning or good evening. Hope I am audible. Yes, no, no, yes. People joining after a long weekend. Date 7th. Okay. 10th March. What is this? All right. So hope people are there. Shall we proceed? Can you all able to hear me?
Yeah.
All right. So hope you all gone through the course content. Like in the last session, whatever we had discussed related to Kubernetes, architecture, the purpose of Kubernetes and its architecture components, the terminologies, right? Did you get a chance to go through these notes? Hope it's all clear, right? And today we'll be discussing about the installation and configuration of the open source Kubernetes, right? So this is the plan. And in the last session itself, I gave you the overview or the commands or the process what you're going to do. So we'll be executing all these things today. Got it? And once this is done, I'll show you how to create a pods. Okay. So create and deploy the pods. That is the plan. So I think we can able to cover till this, and if time permits, then we'll move on to the next topic. Like we'll be discussing about the deployment control objects, like as per your course curriculum, right? Like what are things we have there? What we have there? Mm, This is the one, right? So yeah, today we'll see how to install and configure Kubernetes along with your Kubernetes nodes like Masternode and Worker nodes. And then we'll create and deploy the pods. And then we'll be discussing about the deployment controller object and namespaces, everything we'll see one by one. Fine. So any question before I move on to the next topic, or are we good to proceed? Hope you all can able to unmute a line, right?
Yes, Loksai, I have a question. One second, please.
What's the question?
Asking just 1 minute, please. I'm opening my note.
Any other
I
questions
think
from others?
I want to know the difference between kubelet and container D, container runtime interface, which is container D for Kubernetes. Kubelet and container D.
See,
Difference between both of them.
kubelet is a agent. Kubelet is a Kubernetes agent that will be running in all the nodes of your Kubernetes, including a worker node, which is responsible to deploy your pod. Correct?
Okay.
It is responsible to deploy your pod. But when you say container runtime interface, it is a container D which you're going to use here, through which we can able to interact with your container registry and identify the image for deployment. So Kubelet cannot directly interact with your container registry. It will be actually done by your CRI. It is something like a Docker, how it will pull the image into the node, right? Similarly, this container D is used to interact with the container registries and identify the images for deployment. Easy?
Okay.
Right. So any other questions from anyone? Are we good to proceed or any questions? Please let me know. What happened here? Monday you won't speak about? Hmm? Monday you guys don't speak?
No, we can. What happened?
No, I can hear only one voice. Others are muted. Huh? All right, then I'll mute everyone. Let's focus on this. So on Friday, right, last session. So by the time itself, I shared the steps which you're going to follow. This is something related to Jenkins. So I'll be sharing this documents today. Okay. So from this document, you can able to understand the process of your Kubernetes cluster installation configuration. And this is the official page from where you're going to identify the dependencies and the installation procedures for your Kubernetes, right? So this is one thing. And I'll be launching the nodes now, same as what we have mentioned here. We'll be launching nodes, enabling port numbers, and then changing host name, disabling the swap, installing Docker, CRI, kubelet, kubeadm, kubectl, and then enablement of kubelet agent. Right. And
Also,
now, yeah,
the link which is mentioned here in this document, it is for the open source Kubernetes,
yeah,
not for any managed services.
yeah, it's for open source Kubernetes.
Okay. All right.
For managed service and all, you never install anything. Okay, it is already available as a service. You can utilize it from the console. So
And one more thing for my AWS VM which I created. Today I received uh, an email from them and they are saying that I have already exhausted 85% of my available limit. I don't know how is it even possible.
please check your usage. Go to your billing dashboard and check your resource utilization, how much it is consumed. Remember, on the day one of our AWS account creation, I told you how to get into your billing dashboard.
Yeah.
Just go to this billing and cost management dashboard, click on free tier and check your usage. And that notification is common. Anyone who is consuming 80% of their resource, you'll be getting an alert.
But
So
as per
guys,
my understanding, I haven't utilized 80%. It's too much.
please check your dashboard. You will get the complete picture about your resource utilizations. Right? Fine. Guys, I need all your attention here. Please stay focused. If you have any question, just make a note of it and let me know. correct? So I'm going to exactly follow the process, whatever we're going to have, and this process, what we are going to do, it is same as what we do in a production environment. The the steps, whatever I'm going to share with you, you cannot directly get it from the official documents. If you go to the official page also, you won't get all these things on the same page. You have to navigate. Let's say if you want to set up a unique host name, they just informed you to do that. But how to do that? You have to navigate to this page. Like this, for each and every action, you have to navigate to their, uh, respective pages to understand the process. So I just simplified everything and prepared this document. Even in real-time environment also, you'll be having such a lab or a setup or installation guide or manual. You'll be following it. All right. So I'll be going step by step. The process is lengthy. It will go at least for 40 to 50 minutes. You have to pay attention and stay focused. So let's get into this. AWS first. I'm going to launch 3 nodes. I want to consider 1 for master and 2 for worker nodes. Let me tag it as PL Kubernetes. And I want to choose Ubuntu, that too, the previous version of Ubuntu, 22.04 version. Correct. 22.04 version. Please remember this, okay? It should be 22.04, not the latest one. And instance type, it should be more than your no 2 GB RAM or 2 CPU. Because as per the official documentation, you can see the minimum requirement is you need at least 2 GB RAM or 2 CPUs. Right? Then only your Kubernetes process will be successfully deployed. So for the best practice, if you want, you can choose T2 medium, which will come with 2 CPUs and 4 GB RAM. This will be sufficient for your lab practice, but it is a paid service. You can see the charges, how much it is applicable. Each and every hour, like if you're going with the Linux-based Ubuntu machine, Linux-based machine means this is a process cost actually, correct? So I'm not going to use T2 medium. I'll use T2 micro because our lab or our workload is very less. We are not going to deploy a huge list of applications, just a simple application we deploy. So it is not going to cost you much. If it cost also, you can able to upgrade it. From T2 micro, you can able to upgrade T2 medium in future if you want. So for the demo purpose, I'll go with T2 micro. And if there's any issue occurs because of this, I'll show you how to handle it. And let me choose existing key pair and leave all the parameters default. Okay, don't change anything. Let it be the same. So all that you can do here is enter the tag, choose Ubuntu as 20.04 version. Instance type can be T2 micro for now, and key pair it is the one which you already created, and ensure that you choose 3 number of instances and launch it. So it's all successfully launched. And now go to your instance list. You should be able to see your running instances. And let me just rename it to Kubernetes master. And here, this is my worker node 1. And this is my worker node 2. Right. So this is just the tag we are assigning to refer in the console. Now we are going to log into all these nodes. But before you log in, all that you should do here is you have to add the required number of ports. In real-time environment, you'll be adding these many ports to your nodes. Your master node should have all these ports enabled at least, and worker nodes. For the matter of time, I just allow all traffic. Correct? Because it is just a demo server. Just go to the security group of that instance, choose the security group that is associated to that instance. This security group is common for all these 3 servers. So select their security group and edit inbound rules. Click on add rule. And here you can choose all traffic and choose serial blocks as zeros. Save the rule. Or if you have time, you can go and add all these things one by one. Got it? So now that we have updated our resources with this security group. Once this is done, let's log into all these machines. So I'm going to log into Kubernetes node 1.
Is it master or worker node?
All nodes.
All nodes. Okay. And I just saw in that documentation, looks like you have mentioned some port numbers over there. On what basis you have mentioned them there?
So this is my worker node 2. And this is my worker node 1. And this is my Kubernetes master. All right. So we just logged into all these nodes. All these nodes are enabled with all the port numbers. And I just mentioned the specific number of ports. On what basis I have mentioned it here means Friday itself I showed you in order to implement your Kubernetes cluster, certain number of ports has to be enabled on your machine, right? If you want to know the list of port numbers, click on this link. It will take you to the list of port numbers which are required. That is what I just showed you here. Got it?
Yes, got it. So these
So
numbers are mentioned in that documentation.
So if you want to add ports one by one, then what will be the type there? With type.
don't choose any type, okay? It is a custom
Okay.
type only, right?
Okay.
If you edit the port number 8080 or something, it will automatically change to custom TCP.
Okay.
Fine.
Already you did it, no? In your Jenkins master, how you did that? Tomcat server, how you did that? You have made your custom port number, right? 8080 and all.
It's only
Yes.
80 we have done. Na? Here it is
Ah,
4 5. I thought some different
yeah,
name.
just add new. Just click
Okay.
on add rule and add another level.
Okay.
So I'm on master node 1. And let's update the default packages. Okay. So all the packages are updated here. And now it's all in the document, okay? I just prepared this for your reference. So we just update the package and we have to set the host name now. So sudo hostname CTL. So currently this host name is referred with this IP address. I don't want to use this IP address as a reference. I want to change the name of this node. So I can simply say hostname CTL, set hostname as kmaster node. This is meant for my master node. And if you want to make it as an immediate effect, just execute a command, exec bash command. See, it has changed from IP address to kmaster. Similarly, go to your work node 1 and change the host name as worknode1 and exec bash to verified. Similarly, in workernode2, it should be 2 and exec bash. So once you change the name of that node, host name, even if you reboot your machine or restart your machine, it will always referring to this only. This is something used to quickly identify. Let's say I have deployed a pod. We already talked about the replicas, right? Replicas means we are going to create some copies of the pods and containers, and it will be distributed more than one worker node. So in which node the pod is up and running, if you want to quickly refer that, we'll be using this naming conventions. So once this is done, I'll be disabling this swap, these two commands. This is something helps you to help the kubelet to work properly, because kubelet is the agent that is going to deploy a pod. So in order to make your kubelet deploy a pod, right, this swap off should be executed. So run these commands in Kubernetes master node. As well as in Kubernetes worker node 1, as well as in worker node 2. All right. So we are executing all these commands in all the nodes, including a master node and the worker nodes. As I said already, there are few commands that should be executed in all the nodes, and few commands should be executed only on the master node. So first, let's complete this. We have completed these 3 tasks now. Next, we are going to install Docker. It is completely optional. So there's a command to install it. apt install docker.io. It's installed in all the nodes one by one. Just right click. And once Docker is installed, the next step is to install the CRI containerd in all the nodes. So to install containerd, there are some prerequisites. You have to update the net filter module required for networking, as well as you have to update the IP6 table references for your Kubernetes networking, the pods networking, as well as you have to download the packages that is required for your containerd. Once the packages are downloaded, then only you can able to install the containerd. Upon installation, you have to do some configuration. You have to configure the containerd file to enable your namespaces and control groups. So let's execute this one by one. So I think Docker is installed in all the nodes. Fine. So now let's install containerd. For that, let's first execute these lines of code. Just copy paste. Okay, don't try to manually type the commands. Okay, always it is recommended to use a copy paste, because if there is any typo, then it will be a very difficult for you to troubleshoot the issue. If you have time, that's fine. Otherwise, don't take that risk. So here, once I update the net filter module, I'll be updating the IP6 table references in all the nodes. And then I need to restart, because the table reference, whatever we made now, it should have immediate effect. So let me restart this. Once this is done, then you can able to download your containerd package. To download the containerd package, we'll be using the curl package manager. Got it? So this is a command actually. So using this command, you can able to download and then install. But sometimes in your machine, the curl will not be available. So for that, first you have to install the curl package manager, sudo apt install. If it is there, that's fine. Otherwise, install it. See, it is already there in this machine. The latest version will not have this. Okay, so if curl is already available, then you can directly run this command. Just enter to proceed. Okay. And now let's execute this command in this node. This is just to download, okay? Nothing else. Once the containerd package is downloaded, then you have to update the default packages which you have downloaded and install containerd. I'm taking you through step-by-step process. Please follow this. Yeah, it's installing. And similarly, let's install it in this machine as well as here. So now that containerd has been installed, and once containerd is installed, right, you have to configure the containerd's default configuration file. So to set up the default configuration file for containerd, we are going to create one folder, the directory called containerd directory under etc directory. And we are going to copy the configuration which you just installed into that directory. That file will be saved as config.toml file. This toml is an extension to your containerd config file. So once the toml file is created successfully, then you have to edit that file. Using VI editor, edit that config file. And once the config file is edited, right, in a VI editor, you have to navigate to the file to this particular group. And there will be one parameter called the system DC group. By default, it is false. You have to make it true and save the file and restart containerd service. That's it. So let's edit the toml file now in Kubernetes master node. Go to insert mode, scroll down, you can find one parameter. It's here. It is false now, just make it as true. So it is present in your containerd runtimes.runc options. Okay, make it as true and save the file. Escape :wq. Same thing, you have to run it in all the nodes. Hold on. Unmute yourself, please. Sorry, mute yourself, please. So here, scroll down. And make it as true. Save this file. And similarly, copy this, edit the toml file, go to insert mode. And make it as true. So like this, you have to update your config file. Once it is updated, see the document is very much clear, okay? Like anyone who go through all these things are committed lines. The executable lines are separately here. Any line that starts with a hash, it's a committed line just for information. Once it is updated, just restart the containerd and check the status of containerd. See, in all these nodes, the containerd service is active and up and running. Just give Control C to come out of this command. Control C to exit from any command, right, in Linux. So only if containerd is up and running, you can able to set up your Kubernetes. Setting up Kubernetes means you have to install 3 items. One is kubelet, another thing is kubeadm, and then your kubectl. So to install these 3 items, first you have to download those packages. And then we have to create some keyrings folder to maintain the keys that is associated to that version of that package. And then you can install it. So as part of this, first let me update the default packages. Because we have installed containerd, it must have generated some packages. So let's update it. And once the packages are up to date, then you can execute this command. These are all the prerequisites for your kubeadm and other stuff. And then you can see I'm going to create one folder called keyrings folder under etc/apt directory. Once that folder is ready, you are going to use a curl command. It is a one full command, okay, to download the keyrings file into that folder path. Right? So once the keyrings file is created in the directory, then you have to execute this command. This command is going to actually configure the Kubernetes version, which version of Kubernetes you want to install. It's one command, okay? If you navigate, it might split. Correct. So please ensure that you execute as a single command. And once this is done, you're going to update these packages. What are all the packages you have downloaded so far? We're just updating it. And we are going to install the Kubernetes components. apt install kubelet, kubeadm, and kubectl. It's all under in process. Run it in all the nodes also. It's all done. So once these 3 components are installed in all the nodes, finally you have to enable your agent. Why I'm enabling it means whenever the node gets restarted, the agent should run automatically. It should start automatically. Correct. That's it. So these are all things we have to configure in all the nodes. Any question you can ask me now.
And you said that Docker is optional to install here. It is because we are using container D for
Yes.
downloading the images.
Yes, that's right.
And but still
Right.
that one more thing, Lok Sai, before you proceed ahead, and still the Docker D is getting the images from the Docker Hub registry only.
Yeah.
Okay.
Once you install containerd, the Docker will not be referenced by Kubernetes. Kubernetes will never consider Docker for any of its actions there. It always refers to containerd only. Why we install Docker means sometimes, I mean, if you really want to create any images in the Kubernetes cluster manually, you can use Docker. But usually we never create any images in Kubernetes. Images will be created only in the build environment. Before you actually configure this, your image should be ready in your container registry, right?
Yeah. Hmm.
So that's the reason I said it is optional. So now that we have installed all the required Kubernetes components, and next thing is only on master node. Out of 3 nodes, which node you want to consider as a master? On that node, just execute kubectl init command. This is just to initialize the Kubernetes master node. And then follow the process that the command is going to provide you. Got it? It will provide you some set of actions to be performed. You have to follow that steps to set up your cluster. So go to your Kubernetes master node. And in this master node, you are going to use kubectl init command to initialize it. So this is a simple command, kubectl init followed by the pod network CADR. So yesterday when I was talking about the pod networking, I told you whenever you deploy any pod, the pod will be allocated the unique IP address, correct? To
Yes.
enable the pod networking, every pod will be assigned with a unique IP address. So which component is responsible to assign the IP address?
Proxy.
Kubeproxy,
Yeah.
right? So Kubeproxy is going to assign the pod IP address, means it is based upon this range we are going to provide. And this range also depends upon the network plugin which you're going to install. So in this master node, you have to install the network plugin that is used by your Kubeproxy to set up your CADR range. So in real-time environment, you can simply run this command, kubectl init followed by the pod network CADR range, because there you'll be having your actual infrastructure with 4 GB RAM or 3 CPUs, everything. But in our case, we have used only T2 micro instance, right? Which comes with 1 GB RAM and 1 CPU. Definitely your kubectl init will fail if you run this particular command. So if there is any issue occurs because of the resource unavailability, like your CPU or memory, if any error occurs, we are just giving an instruction to ignore that error. So people who are using T2 micro instance, you can use this command, kubectl init command, along with the flag, ignore preflight error flag for number of CPUs and memory. All right. So this one. So this command, what is going to means, it is going to first download all the images that is required for your Kubernetes cluster. Like in your Kubernetes cluster, we have a scheduler, API server, etcd, right? Controller manager, kubelet, kubeproxy, actually kubeproxy. So all these images are to be downloaded first, and it should be executed as a pod. So that's what this command is going to do. If you want, you can manually download those images. So there is a command called kubeadm config command, followed by the images pull. So this command will first pull all the images. See, it is downloading all the images into your Kubernetes master node. See, it has downloaded the API server, controller manager, scheduler, core DNS, kubeproxy, right? So all these core components are downloaded. I mean, images are downloaded in Kubernetes master node. And once it is downloaded, you can able to run this command. Even without downloading also, you can run it. If it is not present, it will automatically download. Kubeadm init pod into CDR. Use the same CDR block because it is based upon the network plugin. See, it's just processing and it takes up to 4 minutes. It will be done because it's just a very basic setup we are making here. And if you can see here, as part of the execution here, I've used kubectl init command to initialize my Kubernetes master node. And first it is verifying the infrastructure. And it is identifying that the number of available CPU is 1, which is less than the actual requirement. Also, the RAM is less than the actual requirement. But still, it is proceeding further because it is considering it as a warning. We just mention it here. If any error occurs, just ignore and proceed. If you're not using these two tags, then your initialization will fail at this level itself. Easy? Hope you're understanding the process, right? Now, the Kubectl minute is completed. So if you can scroll down, you can see the status. Your Kubernetes control plane has initialized successfully. Control plane means it is an alternate name to your Kubernetes master node. Kubernetes consider it as a control plane. And it is giving some recommendations. Once it is initialized successfully, to start using a Kubernetes cluster, you need to run the following commands. Okay. Like, for example, I want to interact with my Kubernetes. To interact with Kubernetes, I'll need to use kubectl, right? Remember, we talked about it, no? What
Yes.
is kubectl? It is a command and utility to interact with the Kubernetes master node. But how we are going to interact? Are you going to interact as a root user or as a default Ubuntu user or any other DevOps user? Even as a root user, if you want to interact with Kubernetes, you should have access. Root user by default will not have access to that particular Kubernetes. Even the DevOps user or Ubuntu user. So if you want to provide access to any specific user, you have to run this command. So what the command is going to means, it is first going to create a folder called .kube in the home directory of that user. It is a hidden folder. And then it is going to copy the admin.config file that is already installed in your Kubernetes directory to this newly created folder as a config file. And that config file should be protected. Change the ownership of the config file. Only the user should be able to access the config file. The path should be accessible by the owner. So this is how we enable a secure connection or access to your Kubernetes. So you need to run these 3 lines of code to execute any kubectl commands. Please remember this point. But I already shared all these things in your document. So if you can see my document itself here, I have that command. I just copied from the output. Just consider only the executable statements. Okay, line number 641 to 643, these 3 lines, which is available here. Just paste it. That's it. Now, once this is done, you should now deploy a pod network to the cluster. So if you want your kubeproxy to run successfully, it requires a network plugin. So here we are going to use a network plugin called Funnel Network Plugin. I mentioned, right? Install the Funnel Network plugin for kubeproxy. So to install the Funnel Network plugin only, it is giving a recommendation to run this kubectl apply command followed by the network plugin name. So this I have updated my document here. So all that you should do here, just run this command, kubectl apply command. That's it. Kubectl apply followed by the network plugin. Copy this command and run it in your master node. So here you can see that command has installed and configured your Funnel Network plugin. It's all running as a pod in its own namespace. Once this is done, then you can join any node by running the following command. So this is a join command. Kubectl join followed by that master node's IP address and the port number using the token. The token is auto-generated by your Kubernetes init command. So all these things are the outcome of init command. Okay, so you have to preserve this token because this is the only command that you run in your worker node. Remember, I told you, right? On your worker node, just run the kubectl join command. The join command, you can get it from your initialization process. Just copy this and preserve it somewhere. because this has a token. So usually when you try to interact or access your Jenkins slave and Jenkins master node, what was that authentication method?
Token base.
In Jenkins master and slave, we use key-based authentication, SS keys. Remember, public and private key. But here, Kubernetes uses the token-based authentication. This token is something auto-generated. So use this command in all your worker nodes. But before you run that command, you can use a command called kubectl get nodes. Kubectl get nodes is a command that is used to get the list of nodes that are available in your Kubernetes cluster. So as of now, we just have only Kubernetes master node, which is in ready state. And it is a control plane. Correct. Only one node is available. Now let's run this join command in the worker node 1. See, it is initializing and it has executed the command. And now it is giving a recommendation. Run kubectl get nodes command on your control plane to see the node join to the cluster. Again, if you run this command here, see, your worker node 1 is getting attached to your cluster, your master node. It is in not ready state, but in few seconds will be ready. You see? Now, the same join command has to be executed in your worker node 2 as well. See, this is also getting attached. So like this, we'll be updating the nodes one by one to your cluster. And even in future, if you want to implement this, you'll be doing the same process. Let's say today we just have only 2 worker nodes. If you want to add one more worker node, means just perform all these process, install all these packages in that node, and directly use this kubeadm join command. But let's say if you misplace this join command, if you lost this token, okay, and even I just clear the screen here, I lost the token, right? Then how I can generate token and attach a new node means it's very simple. There is a command called kubeadm token creation command. So this one, kubeadm token create, followed by the join command. If you execute this command in your master node, it is used to generate a new token. Just run this command in your master node to create a new token. See, it has created one token along with the command. Just copy this in the new worker node which you want to attach. Am I clear with this?
Yes, so every time we will create a token, it is a new token.
Yeah, it's a new token.
Okay, and we are running that kubeadm command in the worker
Always
nodes
in the
to
master node.
no kubeadm you ran in the worker nodes.
No, we never execute kubeadm in the worker node. In kubeadm, we just run your what do you call that? Token creation, right? You're saying it will be running in your master node. Similarly, if you want to initialize, it will be in your master node. Here, this one, all these things. Try to understand, okay, this is very much important step you should follow. Execute your kubeadm init command only on the master node.
No,
Correct.
please go to the worker node once.
Okay.
Scroll up. Then what is this? Sudo ctm
This is
enable,
to
and then under that
which one? This one,
kubeadm
right?
join. Yeah,
This is a
kubeadm.
join command, right? Not a init command, no?
Okay,
So
so
this
we
command is just to join your worker node to your master node. It is not to initialize anything here. What I mean to say here is, if you want to initialize your master node, always a kubeadm should be executed from your master node only. You're not supposed to execute any worker nodes. Once this is available, it will generate a token. By if you misplace the token, you can again run the same Kubectl token create command in your master node. This one. This should be executed in your master node.
Once we stop the virtual machine, again we start it, so we have to generate a new token, or same token will be valid for that master node we are creating and saving it.
The join action is one-time activity. Once it is joined, whenever you restart your machine, it will automatically get joined to the node.
Okay.
You don't need to join the nodes every time you restart your machine. It's not required.
Okay, so if I once join these two worker nodes with the master node, every day if I want to work, no join command is required. It will be automatically done.
Started. Yeah.
Okay.
You work in Jenkins, right?
Yeah.
You attach your slave node once,
Yes. Yes.
and you can able to restart those two machines any number of times, right? Your
Okay.
slave will automatically get added. Correct. Something like that.
Okay.
So, any other question from anyone?
Yeah, so just wanted to check again. We will be generating the token in the master node, and then we will be establishing the connection by pasting that token in the slave nodes or worker
Worker
node,
node.
let's say.
Yep.
Okay, so this is the process. All right. QVDM join.
All right. So
Yeah.
with this, we have created and configured our Kubernetes cluster with master node and worker nodes. And as I said, in your Kubernetes, we have a lot of components, starting from your API server, etcd, scheduler, controller manager, kube proxy. All these things are actually running as a pod within the cluster. So there is a command called kubectl get pods. When you say kubectl get pods, see, it is saying no resources found in default namespace. If I say kubectl get pods, -, all namespaces. So you can see there are some number of pods. These are the pods name of the pods actually. And it's all in running state. Like you can see your etcd, API server, controller manager, kube proxy, scheduler, core DNS, and the network plugin, whatever we installed. So all these things are running as a pod, and it's all running in its own default namespace. Like your core DNS and all, it runs in its default, which is called kube system. Network plugin runs in kube from network plugin. So namespaces means it is just a logical partitioning of a cluster. It is just an isolated path to deploy or isolated environment to deploy your pod. Correct. And if you want to get the list of namespaces, you can say kubectl get all namespace, sorry, ns. Die. I think there is something called kubectl get ns. So these are all the namespaces available in your cluster. Out of that, we'll be using your default namespace. So if I simply say kubectl get pods, it says no resources found in default namespace. So what it means, this default namespace is something used to deploy the application related pods. Like whenever you create any pod, by default, it will get deployed in the default namespace. All right, as of now, we haven't created anything like that. That's why it is empty. If I say kubectl get pods of from all namespaces. So as of now, these pods are up and running. It is occupying the kube system and kube namespaces. Right. So I'll talk about, okay, we'll talk about the namespaces. We'll talk about the pods creation process one by one. So once your installation configuration is completed, how can you verify the installation? Means this is how it is. You have to execute a command, kubectl get nodes command from your master node to check your nodes details. So the nodes, whatever you attach to your cluster, everything should be in ready state. Means it is in a healthy state. Similarly, you should execute a command called kubectl get pods all namespaces. This command will get you a list of all pods, system pods actually. It should be in running state. If any one pod is not in running state, it means your configuration is not successful. And another important thing is, here you can see the kubectl. It is having 3 replicas of pods. Similarly, the core DNS is having 2 replicas, and kubeproxy is having 3 replicas, right? So when I talk about the pod, the pods will be actually deployed in a node. Whether it is running in the worker node or in the master node, how to get those details means there is an option called -o wide option. See here. I repeat. So you can see when I use kubectl get pods from all namespaces, -o wide. -o means output wide. I want more information. If I simply say kubectl get pods from all namespaces, you'll be getting only the status. That's all. But my intention is I want to know in which node it is running and the IP address of the pod. So you can see along with the status, you can get the IP address of the pod along with the node name. That means this particular version instance of your front network plugin is running in worker node 1. This is running in worker node, Kubernetes master node, and this is in worker node 2. Similarly, your core DNS, both the instances are running in Kubernetes master node, and etcd is running in master node. API server, controller manager, and kubeproxy is having 3 instances. For each node, you can see 1 instance, and scheduler is running in master node. And this is a unique IP address assigned 10.244.02. And this IP address assigned to that particular system component. Correct? So this is how we verify the installation configuration of a Kubernetes cluster. Any question?
Not now. One thing just want to ask: the IP address which is mentioned for the worker nodes over there, where you typed "o wide" something command. So will that match the IP address IPv4 public address of the virtual
No,
machine?
no, it depends. It depends upon your master node. It depends upon your master node as well as the network plugin which you use. So if you can see here, kubectl init command, while giving the kubectl init command, I use pod network area range 10.244.0s. Based upon this range only, the pod IP address will be assigned for any component. But apart from this, for all the core system components, right, for all the core system component means like, I mean to say your kubeadm, sorry, what is it called? etcd, API server, for all those things, it will be assigning with the system IP addresses, depends upon that. And even tomorrow, if you try to deploy any pod, any application pod, it will be assigned with its own IP address. So that is how it just manages thing. And also, if you can see here, I used one command, kubeadm join command. If you noticed here, right? Where is it? This one. So when we say kubeadm join command, we are trying to use the
Yes.
IP address of that machine. right?
Your screen is static. Now it is
Here
visible.
I'm talking about this Kubectl join command, right? So this command, it is using the IP address along the port number. So the one which I used in my machine, Kubectl join followed by the IP address. So this IP address belongs to your node, that is your master node. Can you see this? So from your Kubernetes worker node, you're trying to connect to your master node using this private IP address and the port number 6443. This is what I mentioned initially. You have to enable certain number of ports, right, for your master node. I think it should be somewhere here. Say 6443. Like this, each and every IP port number has its own significance. Got it? So that's it. That's about your installation configuration of your Kubernetes cluster. If you are clear with this, then we'll see how to create our user application pods. Because the pods, whatever you are seeing here, it's all the system components. Nothing is running in default namespace. If you want, you can able to create a new pod. Shall we? Or you want to have a quick break?
Yeah, please break. 5 minutes just.
Is it? Yeah. It's all understandable to all, or like any challenges in understanding things?
Pretty much understandable. The best thing is that you consolidated everything in this document for the installation of Kubernetes. Otherwise, I would have taken around a week to install it.
How about others?
Yeah, easy. Yeah.
It's good.
Any challenges in understanding things? Hope you can understand what we're actually doing in each and every stage. Commands, you don't need to worry, okay? The commands and all, you don't need to remember and all. Even we never remember any commands. It's all from your official page. You have to refer. Got it? And don't try to memorize any commands and all, okay? It's totally waste of time because it depends upon the version of your package which you install. So always it is recommended to go to the official page, understand the process and the commands and execute the same. Easy? Carry on.
I just want to know from where you got that CID or IP address.
It's based upon your network plugin.
Okay.
The funnel network plugin which we use, right? If you go through the properties of that funnel network plugin, it uses that range. Like that, we have Calico network plugin. It will be having its own range of IP address.
Okay.
Hmm? What the? So shall we?
Yeah, sure.
Okay. So next item in the list is about deploying your pods, creating a deployment controller objects, working with deployment controller objects for rolling updates, rollback, scaling up or scaling down, and then services. Um, okay. So we'll be talking about the creation and deployment of pods, and then we'll discuss about the services. Do you remember in our Docker module, we have discussed something about your port mapping, right?
Yes.
So
Yes.
what is a port mapping there? What is the need for port mapping?
To expose the application to the internet.
Yes. So if you have any application running inside a container, and if you want to expose the container to internet, we have to do port mapping. That's what we did in our previous module with your containerized workload, right? Same way in Kubernetes, if you want to deploy any application or if you want to deploy your containerized application, you're not going to deploy directly as a container. You'll be deploying it as a pod, correct? So consider I have a three-tier application architecture. The same example we can consider here. So if it is Kubernetes, we never consider all these things as a container, we consider as a pod. This is pod one. Correct. So this is how the pod instance will be created. You can able to create some replicas of pod. So you have front end a pod with 3 replicas, back end pod with 3 replicas, and what else called application pod with 3 replicas. Like this, each and every replica of pod can be deployed in your target machine. That is your worker node. And if you can see here, the pods, whatever we have created here, even if it is not a instances, or even if it is just one instance of pod, that doesn't matter. Okay, consider we just have only one version of pod deployed for each and every layer. Now, out of these 3 pods, which pod you will execute, or which pod you will expose to internet?
I believe front end layer.
So the pod 1 should be exposed to internet, and pod 2 and pod 3 should be within the cluster. The scope of the pod 1, pod 2 is within the cluster, but the pod 1 can be accessible through internet. It can be accessed beyond your cluster limit. So how I can expose my pod to internet? Here in Kubernetes, we use a concept called services. So Kubernetes supports 3 types of services. One, we call it as a cluster IP service. Second thing is your node port service. The third type is your load balancer service. Kubernetes supports 3 types of services. The first type is the default. Means it is to access pods within the cluster. Correct. So it means whenever you create any pod, by default, the scope of the pod is within the cluster. You cannot expose it to internet because every pod service you create, it will be of type cluster IP service. Cluster IP means the pod, whatever you created, it is limited within your cluster. You cannot expose it to internet. But if you want to expose any pod to internet, in the case you can use node port service. So this is to expose the pods to internet. So usually how we expose our containers to internet, we use a port number, right? The port number of the host machine and the container port, correct? Similarly, here we use a port called node port. Node port is a special range of port. It is not as like your host port. In host port itself, it is of special categories. So there are certain number of node ports created, like 30,000 to 32,767. This is a range of port numbers. Based upon this range only, your node port will be created. Let's say if I try to expose my pod to internet, and if I create a node port service to this pod, it will allocate one port number, and the port number will be in this range. It can be anything, can be 30,000 or 31,000 or whatever. You see? So once the port number is assigned, using the public IP address, or we call this external IP address, of node followed by the node port. Number we can able to access through internet. Easy. Understood? This is about your node port service. I'll show you a demo of how to use a node port service, how to expose your pods, everything. And apart from this, the last item is something about load balance service. This is to access the application. Okay. through internet. So this will be um, that is the service is created at the application level. Okay, not at any service level, because my web application can have a number of services. Each and every service can be exposed to internet, means it is possible. But apart from that, if you want to enable your load balancer, you can able to use your load balancer service, and this is not your Kubernetes component. The load balancer is not the Kubernetes service. It should be procured by the cloud service providers, or we can select service providers. Like AWS or Azure or your Google Cloud Platform service. Like, I'm not sure how many of you noticed it. In your AWS cloud itself, there is a service called load balancer service. Can you see this? It is a service that is used to access your application, that will provide elastic scale to automatically add more resources and route your request. So usually when you try to access your web application, let's say if you're accessing gmail.com or if you're using google.com, there'll be incoming traffic from thousands and thousands of users at the same time. So when you try to send n number of requests to a particular application, right, how that request is being processed, how it is exactly mapping your request to the corresponding microservice, that is done through your load balancer. So elastic load balancing scales your load balancer capacity automatically in response to your incoming traffic. And for that, there are a lot of rules actually implemented. Okay, I'll talk about that. If time permits, we'll talk about all those advanced topics. But as of now, understand, load balancer is not something from Kubernetes. We are going to rely on this particular service for that. And this is a costly service. It's a paid service. You cannot get load balancer from any service provider for free of cost. Correct. If you want to enable your deployment in Kubernetes, load balancer is one of the paid service we have to avail. Correct. And it is promptly meant for a production workload. For non-prod workload, we never use it, but for production implementation, definitely we need one. Easy. So understand the purpose of it. Your cluster IP service used to access your pod within your cluster, where it limit the scope. Because if I expose all these pods to internet, end users might access the database, right? We never allow the end users to access the database service or the application layer. They'll be having access only to the user interface. So just expose it using node port service. And for all other pods, you can have your cluster IP by default. Like this, if you have thousands of microservices, this is one service, right? Like user login service, right? Like this, one application will be having thousands of services. Each and every service will be having one node port. And if you enter your gmail.com and if you click on that user login or sign button, from that gmail.com page URL, the control will be routed to that user login page. Similarly, if you try to click on user registration page, the control will be routed to the corresponding page. So from your root URL, that is gmail.com, there is a root URL. That is a host IP or host address. From there, it is going to route it to the corresponding services through your load balancer. You see? And it is applicable at the application level. All right. So we are not going to have any demo on this load balance service. It is something related to your load balancer that is a paid service. Tomorrow, once you start using your AWS module or Azure or Google, you will be using this, such managed services there. For this open source DevOps services, we are not going to use this, but you'll be using this node port service. I'll show you how to create node port service and expose your pod to internet. Right. So now, if you're clear with this, then I'll show you how we can deploy a pod. So to deploy any pod, what is the basic requirement? First thing, you have to create a manifest file. And this manifest file should be in the form of YAML or JSON. Kubernetes supports both YAML as well as JSON file formats you can create. And once a file is created, use kubectl create or apply command -f followed by the file name. So this is to submit the pod, or I can select Kubernetes object creation request. So kubectl create followed by the file name -f is used to refer the name of the file. So in that file, what are all the objects you want to create, you just define it. It can be a pod or a service or a namespace or whatever you want to create, just define it here. So what are things you define in this file? Your kubectl will create that object based upon the file reference. Easy? Am I making things clear to all?
Yes, and we will be receiving this
Yes, sir.
YAML file from the developers, right? Manifest file.
These manifest files will be maintained in the source code repository by the
Okay.
developers with the support of Kubernetes team.
Okay. And what was the other file name? One is .yaml, and what was the other one? JSON.
JSON file format.
Please type it there beside the YAML. You
It
can
can be a JSON file or a YAML file. Okay, anything. Kubernetes supports both.
JSON. Okay.
Both are based upon the key value pair. Are you aware of uh, XML files?
No.
So these are all some files, okay, like XML file not aware. Like in Jenkins also we've seen, right? Jenkins uses XML file as its configuration file, everything. Jenkins configuration file, everything is based upon XML only. The
Yes,
user,
form and
everything,
.xml. Okay.
form.xml.
right? The form XML file.
Mm.
So your XML files are based upon the tag. Like it'll be having a start tag and end tag, right? It was used in initial or previous versions of your, tool stack. But the latest version, whenever you're trying to enable some APIs and other stuff, you'll be using the file as YAML file. YAML file is a very frequently used file because of its very easy way to create and manage a key value pair. It is a declarative. And any script you create, it will be based upon the declarative scripts. Correct? So in Kubernetes, we'll be writing some YAML files to create this pod definitions. So I'll give you one small example now, like how to create a pod and what are the terms we use there. Listen carefully. So just look into this scenario. This particular manifest file, it is used to create a pod. I just want to create a file name called nginx-pod.yaml. Nginx-pod is a file name, YAML is the extension. So using v-editor, you can create this file in the master node, Kubernetes master node. listen all of you please. If you want to create any manifest file, you should use some common parameters. That is the API version, kind, metadata, and then spec. So these are the 4 important key value pairs should be used in any manifest file you create. So the kind key, kind is a key and pod is a value. Kind is used to identify the type of object you want to create. If you want to create a pod, the value of the kind key should be pod. If you want to create a service, it should be service. If you want to create a namespace, it should be namespace. So what type of Kubernetes object you want to create, enter the type of object using kind key. And based upon the type of object, you have to mention the API version. API version, it is something used to identify the version of API associated to that Kubernetes object. Let's say, for example, if you want to create a pod, means the API version of pod is v1. Similarly, if you want to create a namespace, the API version of namespace is v1. Or if you want to create a service, the API version of service is v1. Sometimes you'll be using some deployment objects, right? Such things will be having app/v1. So v1 is considered as a core API, which was introduced in the very initial version of Kubernetes. When Kubernetes was introduced for the very first time, the objects, whatever you can able to create using the Kubernetes, was assigned with core version. Over the period of time, when they introduce new features and new objects, they just change the name of that API version. We have a lot of examples. I'll show you one by one. So please remember, whenever you create any pod, means the API version of pod is v1. Correct. Now, the next item in the list is about the metadata. So my intention is to create the pod. What is the name of the pod I want to create? That will be decided by this name tag here. Name followed by that value. So this nginx-pod is the name of the pod which I want to create now. It is something like when you create a container, you are asking the name of the container, right? Like that, pod will be having its own name. And every time we cannot rely on the name, we need some additional tags to that object, like labels. So labels are just an alternative tag to that object. Sometimes, we'll be creating a pod for a specific team. So I can just simply say like team as dev team 1. And whenever I create a pod, I can attach the tag so that I can able to apply some filters. Tomorrow, if you want to get the list of pods that are created for team 1, means I can simply use a label and filter the pods. Got it? So labels are optional in this case, but it is very much important. Got it? It's very much important for enhanced implementations. Got it? I'll show you how it can be referred, especially tomorrow while working on deployments will be useful. And as I said, pod is a collection of containers, right? Using pod, we're going to deploy or create a container, correct? Or run a container. Remember, in our architecture diagram I showed you,
Yes, yes.
if this is a pod, within the pod, you're going to have a container. So if you're going to have a container, means what is the name of the container, which image the container is going to use, what is the version of the image, and what is the port for the container. All these things will be defined in this spec. So the spec key is used to define the container specification. Containers and name of the container. Nginx-container is a name. This value can be anything as per your process. And the image name should be exactly same which you have in your container registry. So Nginx is one of the images. It is one of the web application server. As like we use Tomcat, Nginx is another image. And Nginx runs in port 80. So I use port container port as 80 here. Easy. So please listen one thing very carefully. Whenever we try to create any pod or any Kubernetes object, we should have three tags very much important. One is API version, kind, metadata, and spec. I repeat, kind is used to identify the type of object you want to create. API version is used to identify the API version associated to that type of object. Metadata, it is used to assign the name of that object. And labels are just some additional tags you can assign to that object, not to apply some filter. And spec is used to define the container specification, which can have the name of the container, image, and then the port numbers. Sometimes we'll be attaching some volumes also, like in a container, we use some volumes, right? We mounted some volumes to your container, right? Like that, if you want to mount some volume to a container, all those things can be done in this specification. Hope it's understandable, right, for all? This is how we write our manifest file. Once a file is created, you have to use your kubectl command. Kubectl create -f followed by the file name. I gave you an example, right? Kubectl create or apply followed by the file name. So if you want to create the file for the very first time, you can use create command. Or if you want to create and replace the file, you can use apply command. For example, consider I just want to create this pod manually. If the pod is getting created for the very first time, means you can use your this one, that is create command. Correct. But apart from that, consider I'm making some incremental changes in my pod. Developers, they're not going to create only one version of source code, right? They'll be creating a number of code versions, right? That is the reason they use GitHub repositories. Remember,
Yes,
whenever
correct.
they make any incremental changes for each and every version of the source code, they will try to deploy it. They will try to update or create the new pod. So in that case, they can use apply command. So usually this apply command will be using it in our CSD pipeline. Correct. So this will create a pod, and once a pod is created using get command, you can get the uh, name of the pod and the properties of the pod, and you can able to explore the features, everything. Right. So let's create one.
Loksai, earlier you were saying, if I'm not wrong, that we'll be getting that manifest file from the developers, and this time you are saying that we'll be creating the manifest file.
I said developers will be maintaining the manifest file in the source code repository with the
Hmm.
help of the Kubernetes team. Right.
Yes.
Developers are the core business application developers. Okay. By default, they will not have any knowledge about Kubernetes. Kubernetes is something used to deploy your containerized workload to the target environment. So if you ask any developer to directly write this manifest file, they will not have any clue about what it is all about. That is the reason we have Kubernetes developer, Kubernetes administrator in place. Got it? So we will help the developers to create this manifest file, because only developers will know what is the name of the object they want to create, what is the name of the image and the version they want to use, which port number they want to use to deploy the application, right? What is the tag they want to assign. So it is something like a template. We just share this file with them, and they can able to customize. They can able to change the name, labels, or image as per their need. But they will never create this from the scratch. They just update the file as per the need. This template should be provided by the Kubernetes team.
Got it. So this is the default template.
Hmm.
And
Yeah.
the thing which is mentioned here with the image, like nginx image and container port 80, so this we can find in the Docker or registry as well under the layers.
Yes.
Okay.
So I'm on Kubernetes master node now. I'm going to create one manifest file. The file name I can use as nginx-pod.yaml. So vi, I can do one thing. I can create a folder here, mkdir Kubernetes. So as a root user, I have created this folder in the root directory. Now, let me create a file, vi, followed by that file name, nginx-pod. Go to insert mode, and you can have all these things there. So while writing the Kubernetes manifest file, if you're using the YAML script, means you have to be very careful with the indentation here. So this is the key and this is a value. This is one-to-one mapping. If you look into this metadata, this is a key that is going to have some set of key value pairs, right? So the grouping should be maintained properly. Just give 2 character space and have the indentation, because this manifest file is case sensitive as well as space sensitive. Without this character space, if you start from this level, it will throw in syntax error. Correct. So we have to pay more attention while using the manifest file. Just give 2 character space. That's enough. Just have the indentation. That's it. Got it. And then the keys, what are you seeing here, like kind, metadata, name, label, all these things are keywords from Kubernetes. If you go to the official page, you will understand how to write a Kubernetes manifest file, what are all the keys available. Got it? So here we're going to create a pod. Its version is v1, and this is the name of the pod which you want to create. These are the labels. This is the container name, image, and the pod port number. Sorry, container port number. Save the file. Now, if I simply say kubectl get pods, see, we don't have anything here. No resources found in default namespace. It is empty, right? There is no pod. So what I can do, I just create a file in this directory. So from the same directory, I should run a command kubectl create -f followed by the file name. Kubectl create -f followed by the file name. This is syntax. Once you exit this command, see the pod, nginx pod has been created. Now, if you say kubectl get pods, you can see this nginx pod, it is getting created now. It's done. It's up and running. It is running with only one instance because we haven't created any replicas. We just created only one copy of pod. It is up and running. Correct. So the pod, whatever I created, I can get the status of the pod by using kubectl get pods command. But apart from that, if you want to know the IP address of the pod or the worker node where it is deployed, you can use -o void parameter. See here. So this is a pod which we just deployed. It is in running state, and this is the IP address assigned to the pod. So this IP is something based upon your pod network plugin. And this pod is deployed in worker node 1. Right. Don't worry, I just shared all these command options here in notes also. I'll be sharing these notes with you today. And there's another command called kubectl get pods -o YAML. So remember, we talked about etcd, right? What is etcd?
It's a kind of database.
Database.
So it is going to maintain a single point of information. Okay, whenever you want to collect any information about Kubernetes and its components, It is actually stored in that etcd directory. It is a directory or database which maintains information about Kubernetes. Whatever you deploy, whatever you run, whenever you try to use get command, it is actually pulling data from the etcd. So to deploy this pod, I have prepared this manifest file. I just prepared the manifest file with these 4 keys and values. But internally, how this manifest file is stored in etcd means it is based upon this one. This is the actual content present in your etcd for this pod deployment. See the API version which you assigned, kind, metadata, we are seeing the labels like nginx, dev, and the name. It is running default namespace, right? This is a container image which we assigned. This is a container which we assigned, container port. Apart from that, all other parameters related to the volume, security, everything will be assigned by your Kubernetes. And this is a host IP address where the pod is up and running, worker 2. And this is a pod IP address. Correct. So while getting the kubectl get pods, this command is just to get the status of a pod. If you say -o void, this will get you the IP address and the worker node of the pod which is deployed. And instead of you say YAML, you can get the complete information about the pod, which is actually defined in your system. Correct. And apart from this, there is another important command is describe command. This is very much important. So kubectl describe pod followed by the name of the pod. So when you say kubectl describe pod followed by the name, our intention is to understand the pod's properties. So in Kubernetes, this describe command is considered as a debugging or diagnosing tool. Sometimes what happens, your application team, they must have deployed some pod. Pod must be up and running. If they get the status of pod, it says pod is up and running, but they may not get the response from the pod. Sometimes your application might be taking a lot of resource consumption, a lot of things might be there. So in such situations, how you can able to diagnose the issue? So in order to diagnose your pod execution status or the process, you use your describe command. So this describe command will get you the complete picture about the pod, like what is the name, in which names is running, which service account it is using, when it is started, what are the labels we assigned, what is the current status, and its IP address, right? And also name of the container, which container ID, the container whatever created by the container D. See that container D has created this and this nginx image name. This is the image ID and the port number. As of now, it is not mapped with your host port. That's why host port is 0 here. It is having only the container port. And then the mount point of the particular container. And this is the conditions. And a very important thing, why we go for this describe command means actually to get the events. So starting from the container creation state, what all the events happen in the pod, everything will be logged here. So if any issue occurs during the container creation stage or pulling the image or whatever, right, it can be listed here. It's like kind of log list of events that happens in your pod. You see? So describe command, it is considered as a diagnosing tool. It is a first level of diagnosing your Kubernetes object. It is not just for pod, it is meant for any Kubernetes object. All right. So any question you guys have, please let me know till this.
Looks like I have a question. You created a pod on the master node. Go back to that screen, please. Other one.
What's the question?
You created that pod on the master node, right? and then it got deployed on the worker node 1, I believe, or 2 it was, I'm not sure. So how that got deployed there? Using scheduler
That's what we discussed, right? What is the purpose of scheduler here?
to deploy the pods
It
depending upon
is
the
used to identify the healthy node for deployment.
uh,
Correct. API server will verify your request and update the etcd. Then scheduler will identify the requirement and choose the best node that is suitable for your deployment. So scheduler is responsible to identify the healthy node. Work node 1, which is assigned here, it is something assigned by the scheduler.
so that is automated.
Yeah.
So I was just confirming if you have mentioned it specifically somewhere or not. So I was a little confused. Now it is
It
fine.
is completely the scheduler's responsibility to choose the
Hmm.
healthy node.
Hmm. Correct, correct. But still, I had this doubt, so I asked.
So yeah, that's it. So it's clear, right, how the process is happening here. Hmm? Now, in our container module, right, we talked about the Docker run command and also we have seen how to log into a container, right? So how you log into a container, which is the command to log in,
Docker
all of
start.
you? Docker?
Start.
My question is how you can log into your running container.
Docker
Ah,
exec.
XCC.
Hmm.
Docker EX.
Yes, Docker exec command is used to log into your running container. Similarly, in Kubernetes, I have a pod that is up and running now, correct? How to log into your running pod? For that, we use a command called kubectl exec in interactive mode, -it, followed by the pod name in a bash mode. There we used Docker exec-it followed by the container ID and in bash mode. Now it is this one. So now you can see the control, it logged into your pod now. From your master node, we just logged into the pod. And now if I say ls, I can able to see the entire file system associated to that, right? And if you are using your Tomcat means, you know the default directory for Tomcat, right? What is the default directory for Tomcat? Tomcat web apps is the default directory where you can see your Tomcat web applications deployed. Similarly, in Nginx image, the default directory for Nginx is users shared directory, this one. So if we can navigate to this directory here, cd/user/share/nginx. This is the installation path for Nginx. And if you say ls, you can able to see the HTML folder. Navigate to the HTML folder, you can see the HTML components like index.html. So if you want to deploy any components or any applications, you'll be deploying it here only. As like how we deploy our WAR file in the Tomcats web apps folder. If you're working in Nginx, your web applications is just index HTML page. It'll get deployed here. You see, if you want, you can be able to create your own HTML file. That's possible. Got it?
so
Like
we
Yes.
need
this,
to
you can
deploy
able
that
to explore.
artifacts.
Sorry?
Art. We need to deploy that artifacts, the war file and jar file in this here.
See, it is all based upon image, right? What type of image you're using. As of now, I just use a base image Nginx. It is having just index.html page. But if you create any web-based applications and if you want to deploy it, means first you'll be packaging it. The image has to be created by the user using Docker file. There it will be
Okay.
packaging of artifacts. Correct?
Okay.
Now, please consider one important thing is whenever you're working in Kubernetes, your image should be already created in your build environment. Okay, we are not going to create an image here. We're just using that image here, right? So like this, you can able to explore, you can able to log into your pod and create some components. Anything is possible here. So now I have index.html. It is a HTML page, right? It's a web page. How I can able to access web page through internet? how to access your web page through internet.
Port mapping.
Port.
In container, we use a term called port mapping, but in Kubernetes, we use a term called
IP.
node port service. I just told you, right? Using node port service, you can able to expose your ports to internet, correct? Easy.
Yes.
So now I'll show you how to expose your port to internet. So there is a command called kubectl expose command. Kubectl expose port followed by the name of the port. So to expose a port, what type of service I want to use means I want to use a type as node port. And while exposing a port, you have to refer the container port. Container port, as per my definition, I use 80. So this is what I need to have here as a container port. So if you run this command, let me exit from this pod first. And now if I say kubectl get svc, svc means the short form for service. As of now, we haven't created any service, but by default, it has created a service for Kubernetes of type cluster IP. That's not a concern now. Let's create one service. So kubectl expose is a command that is used to expose your pod to internet using this node port service. So while using this node port service, you have to map your container port, which is associated to that pod. See, one new service has been created. And now if you say kubectl get service, you can see your Nginx pod service has been created, which is of type node port. And the port numbers, if you noticed, it is just mapping your container port with the node port. See this value 3000, sorry, what is it? 32,427. That is based upon the range. Whenever we create any node port service, it will create a port number based upon this range. So it does dynamically create one port number for our access. See, it is dynamically creating this port number. That is the reason initially I just open all the ports. You noticed? Remember during the installation process I showed you, no?
Yeah,
We enable all the
yes.
traffic.
All traffic.
And why? Because whenever you try to deploy a port, if you create any node port, it creates a range of port number. So this port should be enabled. Correct? So now that we have created a pod and we have exposed the pod to internet. Once a pod is exposed to internet, you can use your external IP address of the node. That means kubectl get pods -o wide die wide. Now this pod is running in work node 1, right? Just go take the IP address of the work node 1. What happened? Here, what I did now? Can you able to see my screen or not?
No, it's stuck.
Why it stuck? What happened?
Not sure.
1 minute here. I think there is something happening here. Okay, let me stop sharing it. Now it's fine, right?
Yeah.
Okay, so you can see my worker node 1. It is responsible to run this pod. Just go to your worker node, pod worker node 1. Take the public IP address, that is the external IP address of the node. Correct? And the node port number. So what is the node port assigned to the service? It is 32427. Simple. Got it? Just run this one. I repeat, once you expose your port to internet, you should be able to see the new service definition is available here of type node port. Whenever you create a node port, it creates a special port number ranging between 30,000 to 32,767. That port is something considered as a host port, and 8 is a container port. So now that container port running inside the pod is mapped with your host port now. Correct. That host port is created by using a node port service. Simple as that. And use the external IP address of your worker node, which is running your application pod, along with the node port, which is generated in your web browser. So just take your web browser and access this. You should be able to see your default page, whatever associated to that application. I think it is loading still.
Even your screen is stuck on our end again.
It's loading here. 1 minute. Where is it? This one. So you can use the external IP address of your node where your application is up and running along with your application. But if you can see here, as of now, this particular pod, whatever we executed, it is just having the basic index.html page. So in the next session, I will show you how we can able to create our own web application in this particular path, and we can able to expose it to internet and access it. Correct. So a lot of things are there. Okay, it is all about the deployment, how you can able to deploy application. So as part of today's session, all that you should understand is once your Kubernetes cluster is up and running with all the worker nodes and the master node, in order to deploy your pod, first step is you need to understand how to expose it to internet, because whenever you create any pod, the pod, it can be accessible within your cluster or it can be exposed to internet. So what is a cluster IP service? What is a node port service? What is the difference between all these two things? Right. Once you're clear with these two things, then only you can able to assign the service to the respective pod type, whether it's a front end or application or back end. Once this is done, in the next level, you can go ahead and give the pod, write the pod definition, create a manifest file, and then use your what do you call that? Kubectl commands to create the pod, get the pod details, describe everything. And once the process completes, if you want to expose your pod to internet, you can able to use kubectl expose command. Got it? So in the next session, I will show you how you can deploy your own application. Like consider in our previous session, we have created one image and published to container registry, right? The Tomcat image something.
Yeah.
I hope all your images are there in the container registry, right?
Yeah.
So in next session, I'll show you how you can use your own application image and create a pod and how to create replicas of it. Because the main agenda for using Kubernetes is to ensure high availability, correct? As of now, we just created only one pod, right? If this pod is down or if that worker node 1 is down, your entire application will be down. So there is no point in just creating a pod. The actual use cases will be creating a pod using some controller manager. What is a controller manager? We'll talk about it tomorrow. Don't worry. Don't think too much about it. Tomorrow we'll see how to create some replicas of pod using controller manager to ensure high availability of your pod applications. Easy?
Yeah. Looks like I have just two questions.
Okay.
What happened when you tried to expose that IP address to internet? Because your screen was stuck, you weren't able to see anything.
Nothing. I just showing you how you can able to create your node port service and expose your application ports. But the image, whatever you use, it does not have any application to access, right? So
Yeah.
tomorrow I'll show you how you can able to access your application and create a pod based on that. Simple.
Okay. And the second thing is, you opened one HTML file.
Mhm.
Uh, I saw some of the script was written there. Was written there.
Okay.
So from where did that come?
It's a base image, right? When you download or when you install Nginx, it gets
Uh,
installed in the default directory, like
yeah.
your user slash share slash Nginx.
Uh-huh.
There you can able to find the default web page of Nginx. Like for
Okay.
example, when you install Tomcat, you can able to access the Tomcat default page, right?
Yeah.
So the default page is available in your Tomcat's web app folder.
Correct.
Similarly, the default page of Nginx is present in the Nginx folder.
.html.
Yeah.
Okay. Fine. Thank you.
One thing, we will be always creating pods in a master node and it will be assigned to worker nodes, any of the by the scheduler, right?
Yeah. So the main objective of Kubernetes master node is to create or define the pods or any Kubernetes objects.
We never create any pods in worker nodes.
We never define anything in worker node,
Okay.
but the pods, whatever we create, it will be actually executed in the worker node
It will be decided by the scheduler, which
scheduler. Yes.
right.
All right.
Yes.
Is that understandable to all? So
Yeah.
today I'll be sharing this class notes along with the installation process, like each and every line, whatever I executed. In front of you, I configured these 3 nodes with all the commands. It went well, right? So if you follow my steps properly, you also can make it successful. But if it is not getting installed or configured successfully, or if your cluster is not up and running, if your node is not getting listed, then you have to reconfigure. No other option. Correct. So please pay attention. Before you do this, understand what you're doing. Simply don't copy paste. Correct. And along with this, I'll be sharing this document also, which helps you to create a pod and describe this. And even if you want, you can log in to this. Okay. Any question?
No.
No, I don't.
Process might looks difficult or might look, hard to digest, because I think for the very first time you're seeing such a huge configuration steps, right?
Hmm.
So maybe it is a new learning. Just consider in the point of view. Correct. Don't think like it's very hard to understand other things and all. Hereafter, it will not work like that. Tomorrow, if you are into real-time environment, if you get an opportunity to work in Kubernetes, that too as the administrator, if you get the opportunity, it's like a lifetime opportunity for DevOps resource. So don't miss that opportunity, okay? It's a very nice role.
Sure. And could you please, Loxai, may I share my screen for once?
What's the question?
I just want you to explain this billing and cost summary. I am not able to get what is mentioned here. It will hardly take a moment, if possible.
See, uh, okay.
Sure.
Others, any questions you have? I think most of you started to log off without knowledge. Without, okay, carry on. You start sharing your screen, please.
Is it visible?
Yeah, go ahead.
Okay. So this is what it is.
What you can understand from here?
Uh, what is this forecasted usage and current usage? I got 1 GB. Then what is this forecasted usage? 3 GB. And
In this month, if you're continuing the usage like this, you'll be using 3 GB. That's what they're expecting.
okay, forecasted usage.
Forecasted usage,
Got it.
right? Currently, you consume 1 GB. So
Uh,
if you're following the same process, they expect you will be using 3 GB, right?
Oh God. So if in case I exceed the limit of 750 hours, so I will create a new AWS account simple using some other Gmail.
That 750 hours is per month usage, okay?
Every month I'll get that.
Yeah, every month you'll be getting 750 hours usage. So monthly you can't create a new account, right? So it's a process, okay? Just I think in your previous module you must have used some container images, right?
Yeah.
Download something. It might
Hmm.
consume, okay? So just go delete all the resources, whatever it is not required now, and you can create a new one as per need. It won't cost you much actually. See, it's all cost in cents actually, nothing else.
Okay. We'll get the paid one if needed. But I think I will need that for sure.
Okay,
Um, no problem. Let's see what happens.
right. So yeah, I have enabled the poll, right? I hope you all can access it or what?
Yeah.
No,
Yeah.
right?
Submitted.
Yes or no?
Submitted.
Yeah, yeah,
Sub-
yes. We
Okay.
have submitted,
So
yes.
for Kubernetes, I have created a folder last week and I think we have updated it for Friday session. So I'll do
Hmm.
one thing. I will update today's session. Today's content. Guys, again, I'm telling you, it's a lengthy content. Don't simply copy paste. Try to understand. Go through the videos and class notes first, and then start your instance. Correct? Don't think like parallelly you can able to start and implement. It will not work because in between, if you make any mistake, again you have to start from the scratch.
Looks like after the completion of Prometheus and Grafana, will you be starting the Azure right after that, or will you be getting some time to practice all these tools?
You can check with your support team on that.
Okay, because it is not as easy as it looks managing it with our office and then study
Okay, how many days you need to practice?
at least a week, to be honest, because it is too much for us, especially for a person like me who belongs to the non-tech background.
But
So what I have done is I have started to give 2 days to each module, like 2 days to Linux and then 2 days to Git, 2 days to Jenkins. But if I want to consolidate everything, I still need a week to practice each and everything again.
sometimes what happens, end of that week, we might feel like to have one more week. As like how you're feeling now, even if we give 1 month also, end of that month, right? You will have the same thought.
uh, but I think with me, the thing is not like
So
what you are
here,
saying.
the next file, what is it? Pods. Okay. Ah, sorry. I'll be
With
sharing
me,
this also.
I would say
Hmm.
little different because managing it with office and then practicing, I listen to your lecture daily. Once I come back from office, it takes 2 hours, then I make notes again in my notebook, it takes again 1.5 hours, then I practice for 2 hours. I hardly sleep for 6 hours. It's too hectic nowadays, honestly speaking.
But you know one thing,
Yeah.
it's just a beginning.
Yeah, that I know, correct.
It's the beginning.
It's just the beginning. Long way to go.
It sounded scary, but let's see what happens. No worries.
No need to get scared actually. See, it's all career, right? Who's going to spend for us, right? We are going to spend our time and effort. Then only we are just, it's building a career. So it's all part of that actually.
Mm, correct.
So it's not about just paying and getting the training. You have to pay. You have to spend your time. That is your actual investment, right? Mm.
Yeah,
So along with your training, you're just spending your time. There is also kind of investment you should consider for your career.
correct.
Okay,
Time
let
I'll never get
me.
back. Money I get every month. No worries in that.
All right. Okay. So I just updated all your notes with the pod definitions, everything. What are things I update here? You can practice that much for tomorrow. I think this itself will be you'll be occupying for tomorrow, right? So once you're
Yeah,
back tomorrow, I'll be talking about the Kubernetes deployment object. Today we covered the Kubernetes pod deployment, and tomorrow it will be on deployment object itself, and we'll be discussing all these things tomorrow. All right.
yeah,
Any other questions you guys have? Please let me know. Otherwise, we can log off.
yeah. Sure. No, I don't have any question. I'm leaving. Bye bye.
All right. Thank you. Thank you all.